Here's the lid to the hot liquor tank. Taking a look at the inside. Right there you can see the impeller. Once again, that's from McMaster car. Running up here to that stainless steel coupler, which then connects it to the shaft of the AC gear motor. Not a real cheap way to stir your water in your hot liquor tank, but it is fairly reliable, and I can speak from experience. If you don't have a substantial enough motor, or in many cases a motor like this that has its own integrated fan to help cool it, you'll burn it up pretty quick, which could be a real drag in the middle of a brew session that would normally be going pretty smoothly. Here you can see the half-inch diameter, 25-foot long copper coil used for the heat exchanger, and it just runs right through the lid there. We got a couple compression fittings leading up to some hex fittings so that we can put on, we got a brass elbow on the right hand side there for the inlet. On the outlet you can just see it goes straight to a quick disconnect. This copper coil is actually marketed at More Beer as a pre-chiller for use when you're cooling your wort. It had garden hose fittings on the top. I cut those off to make the proper length so that they would just, so the fittings would just extend from the lid and keep a pretty nice tight seal so that we don't lose a lot of heat out of the lid there. Once again, you can take a look inside here and see the 1500 watt heating element coming up through the center, and another through the wall thermometer on the left hand side. Again, this rig has been through several different versions, and these through the wall thermometers are from a previous version where they were absolutely necessary. Obviously this one isn't as necessary now, since we have the Johnson A419 that reads the temperature and controls the temperature inside the hot liquor tank. Alright, here's the March 809 pump, used pretty much primarily by home brewers as their sole source of pumps for transferring hot fluids. Just a magnetic impeller, a high temperature pump. It's got the polysulfone head, not the stainless steel or the bronze. I've never had any problems with reliability on the polysulfone heads, even you know, attaching the brass ball valves as you see there. As you can see, I have brass ball valves on the inlet on the right hand side and the outlet on the left. The one on the right for the inlet is always open when the pump is running. You never want to really restrict the inflow here, otherwise you'll get cavitation, which doesn't work well with a non-self-priming pump. I only restrict the outflow, but what is nice is that you can turn off the ball valve there on the right if you have fluid in that hose, and it helps to lock the fluid in that hose so that when you disconnect it and move it around to attach it to other tanks, you don't get hot wort or hot water all over yourself or all over the garage. The orientation here is a little unconventional. Most people set these up so they're mounted horizontally instead of vertically. I did have mine mounted that way at one time. Again, I also had 3/8 inch plumbing on the rig at that time as well, and it was nearly impossible to get the pump primed, and the flow rate was abysmal. Right now I probably get about 3 to 4 gallons per minute flow rate. It's just underneath the 2 tanks here, which it needs to be since it's non-self-priming, it's gravity fed. But I reduced the head on the pump by about 3 feet by not mounting it on the bottom of the rig. Reducing the head obviously is going to increase your flow rate, which is nice when you got a system like this where you're transferring fluid a lot with the pump. During the sparge, as you can see, it's nice and easy just to gravity feed from the mash tun over there on the left hand side to the boil kettle on the right. I just feed it through the bottom ball valve on the boil kettle there, so I don't get any splashing around going on when I'm trying to transfer fluids. Like I said, once again, it works really well, just gravity fed, and using the pump to pump the sparge water from the hot liquor tank over to the mash tun. And here's the latest upgrade to the system. It's a 240 volt AC control panel. It's fed by a 30 amp GFCI outlet in the breaker box in the garage here. Using a probably a bigger cord than I needed to, but this is a 50 amp 4-prong range cord that feeds it. It goes inside to a distribution block, so we can split up hots and the neutral. It's got a separate grounding bar inside. The PID on there, that's 120 volt AC. The switch on the left hand side and the switch on the right are both 20 amp single throw switches. Those are used to control the hot liquor tank on the Johnson A419 controller on the left switch, and on the right switch we have the March 809 pump. The switch in the center is a 30 amp dual pole single throw switch that's used to control both hot legs of power that run to the 5500 watt RIP element in the boil kettle. Maybe not entirely necessary, but it is nice to be able to cut the power completely to the element at will and not rely on the PID or the SSR. Even then, that will only cut one leg. If you have an SSRD, from what I understand, you can cut power to both legs using the PID and one SSRD. Around the back here, you can see the heat sink that protrudes from the back of the control panel itself. It's a 40 amp SSR inside there with the heat sink, and it's really only handling about 23 amps, so it should run pretty cool. Run a few tests and it only gets just warm to the touch. The internal temperature of the control panel doesn't exceed the ambient air temperature by more than 5 or 10 degrees as well.